So we defined curl and divergence. Let's go over example. Suppose I give you the following vector function. I say, hey, my f of x, y, and z is equal to y squared z cubed. And I have 2xyz cubed. And I have 3xy squared z squared. I ask you to find the curl and also the divergence of this vector field. So for the curl of f, we know that we have to put everything in the determinant. So I have I, then j, then k, partial derivative with respect to x, partial derivative with respect to y, and partial derivative with respect to z. And the first component, y squared z cubed, 2x y z cubed, and 3xy squared z squared. Okay, so this guy is equal to I. Partial derivative with respect to y gives me 6xyz squared, minus partial derivative with respect to z, 6xy z squared. Okay, interesting part. So this component is 0, minus j, partial derivative with respect to x, 3y squared z squared, minus partial derivative with respect to z, 3y squared z squared. Again, you got a 0, plus k, partial derivative with respect to x, 2y z cubed, minus partial derivative with respect to y, 2y z cubed. So it happens that this guy is equal to vector 0, 0, 0. This guy represents a vector, everybody. It's not equal to 0 itself. Sometimes they represent this by 0 and a bar on top of it, or 0 bolded. What about the divergence? Divergence of f is basically finding the partial derivative of the first component with respect to x, finding the partial derivative of second component with respect to y, which is 2x z cubed, plus partial derivative of last component with respect to z, 6xy squared z. So the divergence of f is 2x z cubed plus 6xy squared times z. So at any point, like 1, 1, and 1, you can easily find the divergence of f. In this case, is going to be 2 plus 6, which is equal to 8. So note the difference between these two. The curl of f representing a vector. For the divergence, at different values, different points, you get a different divergence.